stuck on a horse, wouldn't you help your Uncle Jack off the horse?
Don't answer that question.
But I can't just pick up where I left off. I would have started.
We were trying to do it really fast.
Yeah, we were. Okay, which one did you say?
58. 57.
57, 58. Whoa, why'd that get so big? Oh my gosh. I did set myself up for that.
Can you erase those?
They're not there. All right, 57. Is that what we said first?
Where's Alpha now?
What is the largest possible value for the slope of the curve? So slope of the curve is derivative, yes? What's the derivative of sine? Cosine. Do I need to do chain rule here? Yes. What is the derivative of x over 2?
It would just be 1/2.
1/2. So now my question, if I want to know the biggest value that this can ever have, well, what's the biggest that this can ever be? What's the biggest value cosine ever becomes? 1. Cosine is never going to get bigger than 1. And then if you multiply that by 1/2, the biggest value would be 1/2. Just a reasoning problem there to think about. You are? No cosine or sine is going to go over 1. 58. Write an equation for the tangent to the curve y equals sine of mx at the origin. So through the point 0, 0. Okay, so this is just write the equation of the tan line through that point. So we need the slope by finding the derivative first. Yep. So this would be cosine mx times m, right? M just being some variable in there. So what is the slope at 0, 0? But I'm plugging in 0 for x. So what's the cosine of 0? So what's the slope? Ironically enough, it's m, the same variable we always use for slope. And so now I do have this point 0, 0. So it's y minus 0 equals slope times x minus 0. That's just point slope. So it's, yeah, you could leave it like that, or you could say this is the same thing as y equals mx. Right. It was just with a variable there instead of a number. $68. Is that where it started going downhill?
What were you teaching yesterday?
Solving equations with rational fractions. So finding an LCD.
I remember like listening to it and I was like, hey, this is like...
Did you say 62? 62f. The square root of f of x at x equals 2. Suppose that the functions and their derivatives have the following value. So f of 2, but it doesn't ask you to find the derivative. Oh, evaluate the derivatives. Okay, so yes, so I would do power rule first, 1/2 times f of x to the negative 1/2.
And then you would do the...
Then I have to chain rule it, right. If it has it right. But in this case, since x is just a value, it's just going to be 1, so it's okay. So here I have 1/2. This is evaluated at 2. So I look in the chart there in the table. F of 2 is 8. 1/2. F prime of 2 is 1/3. So this would be 1 over 2 square root of 8 times 1/3. This is 2 root 2, so that would be 4 root 2 times 1/3. 12 root 2. Or, if you rationalized it, square root of 2 over 24. I don't know how they gave you the answer in the book. They did 1 over 12 root 2. Any of those would be sufficient.
I'm going to ask you on the other maximum, and they why did they they got the derivative of like the one we plugged in. They got the derivative of like the Dydx also before they plug in. I thought once you get the derivative, you can plug in, right?
You can.
Like they got the derivative of the equation or whatever, and then the derivative also
Of the U.
Of the U. Why do they do that?
Well, they chain ruled it. That was the chain rule.
Yeah,
We did that too.
We did, but we didn't have to get the derivative of the U.
You did, because it's got to be du. If you ever have that, because that's the composition. Because what they had was f of u instead of f of x. And so they had to do f prime of u du. Noah, did you have a question about that one? Oh.
What would you do if you saw 2 LGBT
But it's in the square root.
Which part, Aaliyah?
I just can't ever understand.
So I would maybe second for an hour and a half.
Yes. That's right. Then you have to do the derivative. So you got to do -2, g -3, but then you have to do the derivative of g, right? Because that's chain rule. Right. Right.
That's what I'm saying. Why do you change that?
Because you just power ruled it first.
That's the derivative. How would you do it?
-2 g. This was at what? X equals what? 3. This is 62. G of 3. G of 3 is -4. You got -4 to the -3rd. And then G prime of 3 is 5.
Oh, yeah, where's the last
-10
one?
over -64. This goes down in the bottom. And then that can reduce to.
I know all those, but like.
Okay, let's do it. H is a great one.
Is there a rule for when you have to use chain rules?
If there is a function within a function, you have to use chain rule.
So you mean like
That's okay. Like sine.
Okay, so this is a great one. Look at this
sine of
one.
x or something like that?
Any
Well,
I'm not just using
any trig function you gotta be clear.
I see 3 functions here, okay? A square root function, that's 1.
So you do power rule on that first.
Then I've got function squared, that's 2. And then I've got the functions themselves. So I should chain rule. I should have 3 different parts.
And then you have to chain rule 3 different
And
times.
yes. So I'm going to start with the furthest outside, and I'm going to work my way
You might
in.
just write parentheses around the whole thing and put 1 half.
Yes.
That's how I like to do it, so I know that's the outside.
All right, watch what happens.
We only got 4.
Oh, you're talking about radical.
All right. Anybody confused about that? That's the furthest outside.
Now you gotta do the derivative.
All right. Now I'm going to do the derivative under the radical. Okay.
Power rule those.
So
So it's like,
But remember, addition and subtraction are different than multiplication because I can just do those as separate pieces, okay? So this is, again, this is power rule, right? So 2f of x plus 2g of x
they're just one, so it doesn't matter. You don't even gotta do power rule.
times, and now,
But they're just one.
and actually, let me write it this way so you can see. When I do the derivative of this one, I need to come here and do derivative of this because because the derivative of this is its own piece here, right? So the derivative of this piece is power rule and then multiply by the inside. So same thing with g times g prime of x.
Multiply by the derivative. Is that it?
That's not it. That's not it.
Okay, because right now, if I asked you to find the derivative of this, which is the same thing, well, the first thing you would do is power rule, right? This is just like if it was cosine squared x. So you have to do the power first, and then you do the derivative of the inside. Just like here, I would do 2 cosine x. I haven't done the derivative of cosine yet, and then I would come and do negative sine. So it's the same concept.
And then on that one, you would also do the derivative of x.
Right, which in this
If it
case,
was-
x is a specific value, so
Yeah, but if
yeah.
it's like x plus 1.
Right, correct. And then this told me to find this all at 2, 2, 2, 2, 2, 2. So I have 1/2. Somebody said, what's the answer? This is 8 squared plus g of 2 is 2 squared.
No, I don't. You gotta do it.
I just used the chart. So f of 2 is 8. G of 2 is 2. Now I've got 2 times f of 2 is 8. F prime of 2 is 1/3. And then g of 2 is 2. And g prime of 2 is -3. Multiple choice. AP loves these multiple choice questions with a table like this. We have to go through this way. Yep. 1/2, let's see. 64 plus 4 is 68. 16 over 3 minus 12. This would be 36 over 3. Right? If I combine those fractions. Because I end up with, this is 1 over 2 times the square root of 68 times negative 20 over. Oh.
You're doing 16 minus 36. Yeah, you have to do, because it'd be 36 over 3 if you're subtracting. You can count.
So 16 minus 36.
Yeah, so then not negative 16, sorry, negative 20. Yeah.
That's what I got.
You said negative 30 or 36?
12 is 36 over 3.
Oh, that's what I was saying.
When I subtract them, I
That's
get
what I was
negative.
saying.
Okay.
Okay.
Now I'm going to do my little voodoo magic here. I'm going to change this to -10. Well, 20 divided by 2 is 10, so I'm going to do that before I multiply these fractions. So that if I was on a multiple choice and they had a simplified version, maybe it looks something like that. They probably split that 68 up.
How do you split that up?
4 and
4 and
117. So that would be square root of 4 is 2, so it'd be -10 over 6 times square root of 17.
I feel like I don't know some basic math.
That's a lot of that. These simplified versions like this are coming in from if you're struggling with that as your Yeah.
Well, how do you like that?
So the first thing I did was split up that 68. You take the biggest perfect square you can divide it by, which is 4. So 68 is the same thing as the square root of 4 times square root of 17. Square root of 4 is 2. So if this becomes 3 times 2 times the square root of 17, that's where the 6 square root of 17 comes from. It was already there.
Oh, okay, that's the thing. What I did.
Mm-hmm.
There's something
Yeah.
about them all.
Sorry.
It's something about man's mother.
What is 68?
68.
I just saw your mother last night.
No, stop.
And her casket.
Van. Don't follow him up. And don't say things like that. That's
I didn't say anything.
the graph in figure 3.6 shows the variation in average daily temperature in Arizona during a typical 365-day year. The equation that approximates the Fahrenheit is a gross equation. Sine of 2 pi over 365. You just looked at it and gave up. And then it gives you a graph. And I'm just going to kind of something like that. All right, so it says on approximately what day of the year does the daily temperature show the greatest increase from the previous day? So you look at the graph. In other words, where is the slope look like it's the steepest?
Right there at that end of the first day.
So remember, I'm kind of at 0, and then I'm going up, but then I reach a point where it starts leveling back out again, right? So would it make sense to you that right in the middle here is that point where it would? Okay, well you see what I'm getting at, right?
Wait, so what you're saying is it
On a sine graph, that slope of the tangent line is the greatest at that point of inflection where it stops. It kind of
stops going up and starts?
it stops being so steep, right? I mean, here, look at my tangent line here as compared to here. As I make my way up here, it continues to get steeper and steeper, but at some point, it stops being steeper and starts evening back out because I've got to be back to 0 here, right? So where does that happen? Well, it happens halfway between these two, right?
Is it always halfway between?
Well, for a symmetric sine graph, yes.
What about the other side of that?
We learned a little bit about it.
What about what?
What about the line crossing?
Well, that's negative. And it said the greatest increase, right. So I'm going to go with, it looks like about day 100 maybe. Looks like about the greatest, if I'm just estimating. And that's the thing with a lot of these questions is you have to like muddle through the muck that's there to get to what. Well, but that's right.
I'm not sure. I was going to ask you the same thing.
Why is there a?
Leo, where's Allison?
Right.
Where's your girlfriend at?
All right. On about how many degrees per day. Now, degrees per day is a rate. And if I'm talking about a rate, I'm talking about a slope. Okay. And if my y is in degrees and my x is in days, then I'm talking about the slope here. So I'm thinking derivative. About how many degrees per day is the temperature increasing at that time of year? So approximately what is the slope there? So you could, if I had, so I would say you do need this. That's right, yes. the x that you found. So what I'm really looking for is y prime of 100. What is the slope at day 100? So let's do this. It looks worse than it is. All right. Now hold on.
We're plugging it in for X, right? Or no?
All right. Shh, shh, shh. No, not a product rule here. Not a product rule. All right, look. 19.3. Remember, that's just my coefficient out front. Okay? Cosine, negative cosine. Nope. You're right. I'm sorry. Cosine. I did it wrong? Oh. Bless you. I leave everything the same in here. Of course, the derivative of 70 is 0, so don't worry about it. But I have to chain this, right?
Yep.
So times.
No.
70 goes away, why wouldn't 19?
Because it's being multiplied and not added.
That's not true.
So you're saying it's a part of it.
This chain rule for the inside. Look at that closely. If I distributed this through, this is just a constant, so the derivative is 0. The derivative of 2 pi over 365x is 2 pi over 365.
Oh yeah. Now you gotta do the derivative of x minus 101, right?
No, because this is really 2 pi over 365x minus 101 times 2 pi. This is just a constant. It's a nasty constant, but the derivative of a constant is 0. So that's what we're going to plug in. Since that's where we said the slope was the steepest, then we're going to find y prime of 100. What is the slope at 100? So now I just plug in cosine 2 pi over 365. I'm plugging 100 in here, so that would be times negative 1. Maybe we should use 101 instead of 100. Is that what they use? Do you see why I said that?
It'd be 0. And then I would take out your 2 pi.
If I said, okay, I'm going to change this and I'm going to say this is 101 and not 100. No, I just looked at the equation and I said, oh man, if we had evaluated this at 101 instead of 100, that would make this go to 0, which means I'm finding the cosine of 0, and I can do that very easily. So I think I'll do that. Especially since this is a non-calculator problem, right?
Well, the cosine of 0
Is it a calculator?
But because cosine is being multiplied by all that stuff.
It doesn't matter because it's cosine 2 pi over 365 times 101 minus 101, which is 0. So all of this is going to be 0.
It's 1. Then you just got 1 times, then you just got 19.3 times.
Okay, it's a lot easier. Of course, with a if you do have a calculator, it doesn't matter. You can still keep. I was just being. 6, 18, carry 1. I just doubled 19.3.
I thought he was still lying.
I had it. So is that the answer?
That's the answer. And that would be, remember, degrees per day. Don't forget those units. Do you see that it's kind of not as bad as you were making it?
I do. Yes, ma'am, but
I still got a little
are you gonna eat that?
Yes, I'm just a busy doing.
You're eating bread.
Sorry.
No
one pays for like that.
Whatever you don't eat after 20 minutes has to go to somebody else.
You see what I mean?
All right, brain break.
Yeah.
Which one?
Yeah.
Okay, let's take a brain break. I'll come back and do 71, and then we'll jump to the next lesson. 71. The velocity of a heavy meteorite when entering the Earth's atmosphere is inversely I should have told you what inversely proportional means, or reminded you. So inversely proportional means that the velocity, there's some constant that you can divide this way. K is a constant of variation.
What do you want us to do on like that?
I have no idea.
What do you want us to do?
I got to this down like,
Star them right? I don't know.
Like you didn't know, because you didn't know inverse proportional.
It's when we're trying, but it's like I know.
Star that one and we'll talk, yeah. Star that one and we'll talk about it. As long as you didn't star all of them.
Yeah.
But this one I understand because inverse and direct variation, do y'all remember when we did that? You probably don't. I had it in my notes to remind y'all what inverse variation and I forgot. All right, so show that the meteorite's acceleration is inversely proportional to s squared. So we want to show that this happens. This is what we know. This is what we want to show. Yes. Well, they tell you that the velocity is inversely proportional to the square root of s. Inversely proportional means divide. It means there's a constant of variation that you divide by that. Okay? So what I need to do now, how do I get from velocity to acceleration? Derivative, which is also acceleration. So remember, k is a constant. So this is really, yes. It says show that the meteorite's acceleration is inversely proportional to s squared. That means a constant of variation divided by that. If I said that two things were directly proportional, you multiply by k. X and y are directly proportional there. If I say x and y are inversely proportional, then that means y equals k over x.
can I write that down?
Yes. Say that again. Yes. Well, yeah, yes, because it's in the bottom. All right, so this, I'm going to multiply, I'm going to do power rule. So negative 1/2 s to the negative 3/2, right? Oh, I forgot. But then I have to multiply by the derivative inside, right? So I need to multiply by k because k is a constant. That's chain rule. S is not, S is the variable. So now the goal is to get this to look like this.
Not really though. Not really.
We don't need this, we don't need this, we don't need this. It's a constant. It's not another it's not another function. Bless you.
That's what I'm saying.
Okay, so just the power, think about it. If it was 3s to the negative 1/2, you wouldn't do multiply here and then multiply by a 3 on the end. Same thing. We have to look at k as a constant here. That's why. If k was another function, I would have to do that. So this is negative k over 2 s, yeah, it'd be square root of s cubed. Well, this goes in the bottom, right? And then those rational exponents, the bottom is the root, and this stays as the exponent. Is it going to be what? S derivative? Yes, well, it depends on what S is. Gross on this one. Yeah. 3 years ago? 4 years ago? I like taking them. I usually do, like, when y'all do your practice one, they just won't let us. We can't see them unless they release them.
You can't take it if you don't want to?
You mean if I want to? I would love to.
Oh, wait, so you took it before you started taking PCP?
Yeah, that was part of the certification.
Now they make you take it?
And you have to pass or you don't get the certification.
So you can teach the 3?
You could. I didn't. I made a 5. But I'm just saying.
That's good. That's good.
Everybody in there was really, like, wigging out there.
I didn't know if it
Mm-mm.
Did y'all take it out loud?
Well, because you figure some people have been a long time since they've seen that level of math. And we came in there and it was I can't remember if it was 1 week or 2 weeks. But I mean like 8-hour days like in the classroom just. And so we basically recapped calculus in 1 week, 4 8-hour days, and then on the last day we took the exam.
You did calculus for 8 hours.
It was fun. I enjoyed it.
That is almost
But it wasn't all just that. I think 3 of those days he spent going over calculus concepts. But then one day they had like a representative from the college board come in and talk about things and things like that. And then the last day we had to pay. It's because we got college credit. We got like grad credit for it. We got 3-hour credit.
But you didn't get paid that school if you got it.
Well, you probably get paid more.
It's based on your experience and your level of education.
Don't like she doesn't get paid more. She doesn't get paid more than you, right?
She got a JD. No, I'm kidding.
A particle moves along the x-axis with velocity. This is the velocity. This is the velocity. So if this is acceleration, it showed that the particle's acceleration is, they kind of put this in here prematurely, I feel like. I think after today, this one will make a little more sense. So let me do today, and then we'll come back to this because it'll make, yeah. That's because that was our second one. Just so that we're clear, I know, but it's 9:23.
7 minutes.
No,
I
55.
thought we were having a 30-minute break.
Just so we're clear, if I asked you to find the derivative of
Use your power rule and then Dx.
to do product here. This would just be the power rule followed by the chain rule.
I've been sitting here the whole time.
3/5 times 15.
Well, that's just 3. Right?
But now I have to do chain rule. So the derivative of 2x minus 5 is 2. But the point I'm getting to here is as we do this, remember that rational exponents are still Van power rule, right? It doesn't matter if they're a fraction or a whole number or what it is, I still do power rules. Everybody okay there?
Yeah.
Last night's was tough, and I knew last night's was tough. What if it was... What? So same deal here. It is still the power rule, and it is still the chain rule. I just want to make sure that you understand Stop, Dylan. Same rules. -9. Power rule and chain rule. Okay, so I just want you to realize that the rules are still the same as we go through, and I don't want you to look at this and go, oh my gosh, because we're still doing the same rules.
Wait, how'd you get from the first part, how'd you get the step? Oh, wait, that was a different question.
Because it does say 7 right there.
Sorry, that was different.
No, you don't keep chaining. Don't keep chaining until you can't anymore. You just chain and then you're done.
That'd be second derivative.
All right. Let's talk about implicit differentiation. No, that was just a reminder. If y'all do not shut up. Van? Dylan? Van, this is for you because you told me that nothing is done just in steps or anything like that. So I got some steps for you for implicit differentiation.
Dylan has taught me a lot of things. He taught me what BOFA and BOFA and SUGMA and LIGMA, what all of those mean. So I think y'all should.
So here's what we're going to do. We're going to have this equation. Where'd it go?
Lost it, so we can't do it.
Don't worry.
Differentiation, is that the word?
Yes, implicit differentiation.
I want to get back and listen to Connell's recordings.
We were listening to it.
Okay. So we're going to have something like this that says find dy dx. And I think you'll see why when we were deriving before with respect to a different variable, how that comes into play here. So what we're going to do.
Put it as x to the 1/2.
Wait.
I don't know.
That means you're doing dx. Right. You're not, so here I'm going to do the derivative, but I'm going to have to, whatever that derivative is, I'm going to have to follow with the d, let me show you.
Can you, before we do this, can you tell me what, like implicit differentiation?
Means we're going to be doing differentiate, we're going to find derivatives, but it's going to be implicit to just one variable, even though all the variables are going to be all mixed up. Mm-hmm. All right, so this one's different because it's not just y equals. So in this, I'm going to have multiple x's, multiple y's, but I just need dy dx. So it's going to be, this is an easy one because technically I could solve it for y and then find the derivative. But I don't want to do that. I want to solve it the way it is so I can show you what happens. So here's what we do. When we do implicit differentiation, the first thing we are going to do is differentiate each side with respect to x. So what does that mean exactly? That means I basically, it's the chain rule coming out is what it is. If I differentiate y squared, then yes, that's 2y, but I need to find the derivative here with respect to x. So if y has, once I do this, if this meant something else that had a derivative that would chain rule, that's where that comes into play. Okay. And it equals, what's the derivative of x with respect to x? 1.
So just derive both sides.
Derive both sides. But if you ever do, in layman's terms, if you ever do a derivative of a variable that is not what you're doing with respect to, then you have to do d that variable over dx. So if I had, shut up, Dylan. 6, give me a variable, p. If I had 6p and I wanted to find the derivative with respect to x, well, the derivative with respect to p is just 6, but the derivative with respect to x would be 6 dp dx, okay? But with respect to p, it's just 6.
Well, no, because you don't, well, how do you
It's
know?
2y dy dx.
How do you know what the dy
What if
dx
it was,
is, though?
what if
You,
it was,
well, that's what I'm getting to. That's what I want to find because it said find dy dx.
what if it said that first thing y squared equals x, what if it said with respect to y?
Then this would be 2y equals 1 dx dy. Because if it's with respect to another variable, look at this one.
You just go all the way around. I mean, yeah.
If it was with respect to k, it would be dp dk. It would just be 6. Because dp is 1. Okay, so back to this one. Differentiate both sides. This is a super, super easy example that I'm walking through to start with. So I mean, I have to put some other steps in here that will apply to the others. So what I want to do, remember, I'm trying to find dy dx. So what I'm going to do next is I'm going to get all dy dx's on the same side. Dy dx doesn't equal 1. 2y dy dx equals 1. I took the derivative of both sides.
What's that say? Everything else.
Okay, so if this is already separated. 2y dy dx equals 1. It could be that I have 5x plus 7x squared minus 15 dy dx equals 7 dy dx, and I'd have to get those dy dx's on the same side. Okay. All right, so get them all on the same side. And then I'm going to factor out that's what we're going to do. We're going to, in this case, it's already factored out, but remember, some of them won't be like this. We're going to factor out dy dx. So
You gotta get them on the right side.
because the whole goal here, Van wanted steps. That's why I'm doing steps like this.
A little bit.
Because then I'm just going to solve for the dy dx. So divide by. This is implicit differentiation. That's all it is. It's taking the derivative with respect to a variable with other variables involved. So I'm going to do a couple examples that are going to look like your homework. You're done. The whole goal was to find dy dx. I found dy dx. Once you've solved for dy
So
dx,
you get the derivative, then solve.
get the derivative of both sides and then solve it for dy dx. Is essentially what you're doing.
Yeah.
Okay, so let's do an example.
Right.
This is number 2 from your
That
homework.
was a hard I can make the problem if you want. I'm really good at making problems.
Good? Yes.
Well, that's not the hard part, I guess. Let's see here.
Find dy dx.
All right, so basically,
So I'm finding with respect to x. That's the key. That's what you have to remember. Everything's with it. So if you ever take the derivative of, and maybe you need to write this one. If you ever take a derivative of y, you ever take derivative follow it with dy dx.
so you don't have to on the x though. On the x.
On the x, no. X is regular old rules.
Yeah. Okay.
All right.
Wait.
Well, let's do this one together, and then I'll give you you can do by
I thought
yourself.
we were doing this one right there.
Can you?
Yeah.
This is a little bit hard to try to do by yourself to start with. without having worked through an example. All right, derivative of x cubed.
3x squared.
Derivative of y cubed.
3y squared times dy.
There
dx.
you go, dy dx. Don't forget that.
Yep. And then it's going to equal 18x.
All right, now I've got product rule. See?
Why?
And I'm going to do 18x and y as my two pieces here.
I thought you could do 18 coefficient and then x. Well, how do you know you can leave it as coefficient? No.
What do you mean?
Like, when we were doing chain rules, like the ones last night, you just leave it coefficient.
Okay, but there's two variables here.
So,
If you ever take the derivative of y, then you have to follow dy dx because you're taking it with respect to x.
wait, if it's respect to y, though,
Then you would have to follow the
With the
x
x,
with
yeah.
dx dy.
them apples. Yeah.
How about them apples? All right, derivative of the first, 18x
All right.
times, oh, not 18x, 18 times the second. Nope, I didn't take the derivative of that. I did the derivative of the first times the second plus the first times derivative of the second, which is 1 dy dx. Only when you take the derivative. Right?
Hold on. I need that. How did you know when to get the, because, wait.
All right,
Oh,
derivative of the first
got the
times the
derivative.
second.
Yeah.
And then the first times, this is the only time I took the derivative
Because
of
that's
y.
the derivative of y. Yeah,
Right.
Okay.
Y'all okay?
Now we can just solve.
Okay. Now it's kind of downhill. Now you're basically solving an equation with multiple variables for one variable. So, and let me just write it a little bit neater here so you can see. 3y squared dy dx. (18x) dy dx. So here's what I'm going to do. I'm going to take all my dy dx terms and I'm going to get those together on the same side, and everything else I'm going to throw on the other side. Okay? So it doesn't matter which one you move. I'm going to move it over here just because I like them on the left side. And then this one I'm going to throw over here. So 3y squared dy dx.
Wait, they're not like terms of it, do you?
I'm not combining them, I'm just writing them. Remember, this is not so much about the simplification as it is about just finding an equation. Okay. Now, factor out a dy dx because everybody on that side has it. I made sure everybody on that side has it. So I'm going to take it out from everybody. So I'm going to say dy dx times 3. We might in a minute. Right now, we're just concerned about getting... Now, how do you get dy dx by itself? Divide it. That's exactly right. So, dy dx equals 18y minus 3x squared over 3y squared minus 18x. And now I could simplify, if there is some place to simplify on here. And in this case, yes, everybody could get divided by a 3. No. Sorry, I didn't mean to say that. So there is dy dx. So now my derivative has y's in it as well. X's and y's, and that's okay.
I love algebra. I hate
This is completely embedded in
Calculus,
algebra.
it's like both.
It's
like geometry.
It's like both.
It's like both of them. Like both of them. You know?
Okay, let me give y'all one to try.
Because you love it.
That's why your jacket is like annual freaking shoes around.
But look at it all.
Look at this.
High school?
Find dy. You are worried to death about that biscuit. Find dy dx.
So hungry. I should
Your
have went.
parents not feed you enough?
I should have. They're not home. That's home.
Yes.
I always pack well. My mom always packs well.
Of course she does. You're a little petty, Mark. You have to do a little bit. Really? Yes.
Are we doing it in respect?
You
to
have
X?
to do
Van.
Is this with respect to X?
Y'all are supposed to be doing this.
Oh, yeah, pause the video.
Oh, you never said go.
Go. Mark said go.
Is this with?
Correct.
Yeah, it would be zero.
I'm not.
But how are you supposed to do that?
Huh?
Oh, you know you could. You could just change it to X minus Y. You got a what?
So I would not FOIL that denominator. For that denominator, I would move it to the other side and have 2x times x plus y
Can you explain
squared.
how you get the first term?
Exactly that, but now.
But up here, I am going to need to
How can you move that over?
Can you explain how you get that first term, the 1 minus dy?
cross multiply or multiply both sides by that.
How did you get 1 minus dy?
Okay, derivative of the top, derivative of x is 1, derivative of y is dy dx, times the bottom, minus the top whose derivative of the bottom. So this becomes,
Will the derivative of y not be 1?
what?
Will the derivative of y not be 1?
Remember, if you ever take the
I know,
derivative
but
of
then you would
y,
multiply it by dy dx after that. So like, exactly, so it'd actually be 0, because 1 minus 1 is 0. So that's why.
what?
Look, if this was 1, it would turn into 0.
No, why would that turn into 0 if it's 1?
Because 1 minus 1 is 0.
It's not 1 though.
Well, if
It's
x,
1 times the right order. Josie's right, order of operations. If this is 1 times, multiplication comes before subtraction. So I'd have to multiply it first. I am foiling this out. But some things are going to cancel when you do this, so don't get distraught when you see. But we choose not to. All right, this is minus, minus, plus, plus.
oh,
I just foiled. The x's cancel. I got 2 y's. I have 2x dy dx.
yeah, sure do.
These cancel.
Yeah. So does that x? No.
There.
And now you can do a little bit of stuff that I'm not sure what to do about.
I can solve it now. I can move the 2y over.
Yeah, 2y minus, we can use 2y minus 2x.
Okay, I'll wait. Yeah, negative 2y. I'd probably simplify, at least take a 2 out of everybody. And if you want to split it into fractions, you can. It's not really necessary.
When you get to that negative x minus y,
I love these, y'all.
What are you doing from that?
I like it much
I don't
better
think
than
them yet.
the other. Yeah.
Negative x minus y
When
what?
you get to the minus x minus y.
That's second one, sorry. Or were you X out?
Here.
Right, yeah. So what do you do?
I distributed that -3.
Through the whole, those
Yeah.
two things?
Mhm. No, just that parentheses. Everything inside that parentheses
So the
that
one,
follows.
the one up there, the 1 plus dydx.
Where do you see
No,
1
she
plus?
foiled. She foiled.
Oh, yes, I foiled.
So wait.
So, because this is subtracting, so x plus
so you
x
foiled
dy
first
dx.
and then distribute, right?
Yes, yes.
And so all those opposites on the table are off.
See why that first one was a uber easy example to run through. I'm going to divide both sides by -2x. And the question is, can I leave it like that? Well, I would probably at least take a 2 out, maybe even a -2. I would, yeah, I'd probably leave it right there. Yep.
Wait, how did you get,
It's about drive, it's about.
oh, no, don't kill kitten now. Don't do it. How did you take a 2 out of the x plus y then? Well, you asked for maybe. I'm sure he would tell you.
I just divided everybody by -2.
Well, I know, but x plus y does not have -2 and that.
But that's all being multiplied right there, so I can take it out.
So it's not good.
It's not killing a kitten. Yeah. Those kittens really just throw you, don't they?
Yeah, you're not understanding. I miss a lot. I always kill kittens, like with the shotgun too, or straight up RPG. You guys kill dogs.
I do too. Yes.
Yeah.
Now, there's a section on your homework tonight. There are 4 of them.
Chain rule doesn't tell us when to use it, it's just you gotta get out.
You have to remember, nothing has changed about what the derivative is. Even though I have all these, they are going to help or they're not? Okay. Even though I have all these different variables in here, the derivative is still telling me the same thing. What is it telling me? The slope of the tan line. So if I gave you something, you still using that now? If I gave you something like this, 1 -7, and I said find dy dx and find the slope of the curve at that point.
Well, you just put it in points.
If you find dy dx, you found the slope, so you'll just plug this in for x and this in for y, and that'll give you the slope, right, into your equation. Because your equation, remember, has x's and y's in it. So if I took this and I plugged a 1 in for every x and a -7 in for every y, that would be the slope of the line at that
Wait,
point.
but if you're
And then
saying,
once you solve it, you just plug it in.
So it's the same thing. You're just solving, you're finding dy dx, and then you're plugging
if you're
in.
saying find dy dx,
All right, the slope of the line at the point. Find dy dx. You are given all of this. Find dy dx and plug in the point.
if you're saying find dy dx though,
The slope of the curve at that
why
point.
can't we just give the derivative? Why do we have to do like the
Say again.
like if you're saying find dy dx, why can't we just get the derivative?
That is what you're getting. You've just got all these y's in there. Instead of just one y, you've got a bunch of y's in there.
Well, no, this one. It's only got one y. This one.
Well, unless you're going to go through and solve that equation for y.
Like if you just chain ruled both those and.
But if you can only do it with respect to one variable.